This rock, sitting in the red dust of Mars, is at the center of the biggest scientific announcement of our lifetime. Look closer at these dark, organic spots. This month, NASA finally revealed what their analysis has uncovered. In their own words, this is what they believe they've found.
Listen, we can't find another explanation. So this very well could be the clearest sign of life that we've ever found on Mars, which is incredibly exciting.
But what is it about these spots that makes this different from all previous claims? For centuries, Mars has been a mirror for our own hopes and fears about life in the universe. We've seen canals, faces, and fleeting signals, but all of them have faded under scientific scrutiny. This is different. This isn't a blurry photo or a strange radio signal. It's a physical sample, drilled from an ancient riverbed by the Perseverance Rover, a rock nicknamed Chayava Falls, now holding what scientists are cautiously calling a potential biosignature. In this video, we're going to break down the key questions. 1. Why was this exact spot in Jezero Crater chosen from an entire planet? 2. What is the stunning evidence inside this rock that points not just to the building blocks of life, but to a fossilized metabolism? And 3. What are the ghosts of discoveries past that haunt this investigation? And what is the epic, multi-billion-dollar race to bring this rock home for the final verdict? To understand the discovery, you first need to understand the crime scene. For decades, NASA's strategy was simple: follow the water. But the Perseverance mission is far more sophisticated. Its strategy is to find ancient, habitable environments where the chemical fingerprints of life could be preserved for billions of years. That's what led it to Jezero Crater. Billions of years ago, this was a massive lake fed by a winding river delta. And just like river deltas on Earth, it was the perfect place for concentrating and burying organic matter. The rock itself is a sedimentary mudstone. This is a type of rock formed slowly, over millions of years, as the ancient river deposited layers of fine silt and minerals onto the muddy lake bed. As more layers settled on top, their immense weight compacted the layers below, squeezing out water. Eventually, as the lake dried up, the compressed sediment hardened into stone. It's this exact process that often traps and preserves fossils on Earth, as organic remains get caught between the layers and protected by the hardening rock. A perfect geological time capsule. But it wasn't just the water. Orbital scans revealed this delta is rich in specific minerals, clays, and carbonates. On Earth, these are rock stars of preservation. Clay minerals protect organic molecules in their layers, and carbonates can entomb entire microbial communities, essentially creating fossils. What's more, at about 3 billion years old, this is some of the youngest sedimentary rock NASA has explored. This suggests the window for a habitable, water-rich Mars might be far wider than we once thought. Perseverance didn't just land in a place that was wet. It landed in a pre-vetted, high-priority site that met every criterion for preserving the very evidence it was sent to find. Which brings us to the rock itself. On its surface, the rover's cameras spotted strange, organized textures. At the microscopic level, they saw tiny circular nodules, nicknamed poppy seeds, and larger patterns with dark rims called leopard spots. And to be clear on the scale here, even the largest of these leopard spots are only 1 or 2 millimeters across. The life responsible for this would have been microbial. These weren't random flecks. They were signs that a complex chemical reaction had taken place inside the rock. So, the rover brought out its heavy hitters, the Sherlock and Pixel instruments, and what they found is the heart of this entire discovery. The spots were packed with 2 specific iron-rich minerals: vivianite, a type of iron phosphate, and greigite, an iron sulfide. But here's the kicker. The rover's Sherlock instrument also detected strong signals of organic carbon, the stuff of life. And crucially, this carbon wasn't just everywhere. It was found co-located, spatially linked, directly with the vivianite and greigite. This has led scientists to a stunning hypothesis. This isn't just about finding the building blocks of life. This is about finding a fossilized system. Imagine ancient microbes in the mud. They use the organic matter as food, an energy source. To breathe, they use iron and sulfur from the sediment. The mineral waste products of that process are vivianite and greigite. In simple terms, this could be the fossilized byproducts of ancient microbial life. What Perseverance may have found isn't just the ingredients for life. It's the fossilized leftovers of a meal eaten 3.5 billion years ago. The science team knew this was a monumental moment. So, if the evidence is so compelling, why is NASA being so cautious? As the great astronomer Carl Sagan often said, "Extraordinary claims require extraordinary evidence." And science has been here before. We are haunted by the ghosts of discoveries past. In 1976, the Viking landers seemed to find signs of metabolism in the Martian soil. But another instrument found no organic molecules. A contradiction that created a 50-year-old mystery that remains inconclusive to this day. Then, in 1996, scientists announced that a Martian meteorite contained what looked like fossilized microbes. It was a global sensation. But over years of intense debate, plausible non-biological explanations were found for every single piece of evidence. The lesson was learned. Before declaring life, every other possibility must be ruled out. Right now, there are two potential non-biological explanations for the leopard spots. First, could a high-temperature event be the cause? This would involve a process like intense hydrothermal activity or the shock heating from a nearby meteorite impact, where superheated water could have created the mineral spots. But the rover's analysis of the surrounding geology shows no evidence of the rock being baked or thermally altered. The real smoking gun against this theory, however, is the vivianite itself. It's a delicate, hydrated mineral that can only form in low-temperature water. High heat would have destroyed it. The presence of vivianite acts like a geological thermometer, providing clear evidence that this rock has had a gentle, low-temperature history. The second possibility is an acidic water reaction. We know that later periods of Martian history were dominated by highly acidic environments, so it's a plausible idea. But again, the rock itself argues against it. Not only does it lack any signs of being etched by acid, but the rover also found a mineral called olivine mixed in with the mudstone. Olivine is a mineral that readily dissolves in acid, much like sugar dissolves in water. Its presence is a definitive litmus test, telling us that the water in this ancient lakebed was likely fresh, with a near-neutral pH, far more conducive to life as we know it. This leaves the biological theory. By the process of elimination, it's the one that can't be disproven with the data we have. It is the theory most likely to be correct. But that's something a rover, 150 million miles away, simply cannot prove on its own. The instruments on Perseverance have pushed the limits of robotic exploration. They have found the perfect target and asked a profound question, but they can't give us the final answer. To do that, we have to bring the sample home. This is the Mars Sample Return Campaign, arguably the most complex robotic mission ever conceived. It involves a new lander, a fetch rover, a rocket to launch off of Mars, and an orbiter to catch a basketball-sized container in deep space and fly it back to Earth. But it's a mission that's complicated and expensive. As of right now, the US government has balked at the cost, pushing NASA to find cheaper, faster alternatives. And they are no longer the only ones in the game. China's Tianwen-3 mission is on an aggressive timeline to launch in 2028 and return samples by 2032, potentially years ahead of any other effort. A new space race has begun, and the prize is a piece of another world. Once here, in secure labs, scientists will perform the definitive tests. They'll look for isotopic signatures, the preference life shows for certain atoms. They'll search for homochirality, a unique left-handedness or right-handedness of organic molecules that is one of the most unambiguous signs of life we know. So we stand at a historic crossroads. The Perseverance rover has done its job. It has found a target so compelling that it justifies a journey of hundreds of millions of miles to retrieve it. Whether the final answer is biology or a form of complex non-living chemistry we don't yet understand, the result will be revolutionary. It will either confirm that humanity is not alone in the universe, or it will teach us just how convincingly geology can mimic life, knowledge we desperately need as we begin to look for life on worlds orbiting other stars. What do you think is hidden inside the Cheyava Falls rock? Let us know in the comments below. And while we're on the topic of incredible discoveries happening at Mars, you should check out our deep dive on the interstellar comet 3I Atlas and the truth behind its so-called collision course with the red planet. You can click the link on the screen right now to watch that next. As always, if you want to follow the epic story of the Mars sample return missions, be sure to subscribe and hit the bell so you don't miss our future updates.